This is a production of Cornell University.
Okay, this is the soil horizons, or the soil morphology horizons, the distinct different layers within the soil. Now, the way we introduce this is we basically have individuals and we put them in orientation. We have an O, an A, an E, a B, a C, and an R. There is also a W horizon. Okay? Now, before I get too far in this, I want you to realize that not all soils have all of these horizons. And some soils actually have multiples of the same horizon. In fact, this week you're going to see one of those. Okay, so let's go through these horizons and let's talk about what they are. The first horizon is an O horizon. It's predominantly organic. Can we kill the first bank of lights? I don't think you're going to be able to see this. The one closest to me. Try one more. Can you guys see those? Are you going to be able to see some of these? Yeah? Okay. So it is the O horizon. It's predominantly organic. It's an organic surface horizon. It is not present in all soils. And when you start getting into agricultural soils, these are pretty much gone. Okay? It's an O for organic. It's typically in uncultivated forest soils, but you'll also see them in other types of soils. Certainly you'll see them in wetland soils. It is a dark, rich organic horizon. Okay? The decomposition rates, there'll be at different decomposition stages, I should say, not different decomposition rates, but it is driven by organic matter. It is a horizon that is organic matter. It is not mineral. Okay? Often you'll find these buried as well. They can be buried. There can be a horizon way down deep because something could have happened to have deposited on top of it. Okay? The next horizon down is a mineral horizon. It's an A horizon. It is the soil mineral horizon that has the maximum amount of organic matter in it. These soils can be buried as well. So these horizons, there can be multiple A horizons. Okay? It is the soil that has the maximum organic matter in it, and it is also the horizon that has the maximum biological activity. Mineral soil that has the maximum biological activity. Okay? Because it is close to the surface, where it's close to temperature changes, moisture changes, oxygen changes, it is also has huge amount of weathering in it. Both decomposition as well as mineral weathering. Okay? It is also a zone of, or I should say a zone that is the source of a lot of alluviated materials. Okay, alluviated materials means E is the way to remember this, things that are moving out of this horizon. E, alluviation. Okay? This is organic up here, but you can see this nice zone right through here. You can see this nice, it's dark. It's not, it's dark like it's organic because it has organic material in it, but it's still predominantly a mineral soil. Right below this soil, we have an E horizon. Okay? It's fine. Sometimes it's found below the O, directly below an O, but it's usually found below an A, around here. Okay? It is a mineral horizon, and it is strongly eluviated. Okay? Eluviation means things that are stripping through it. Things are running through it, and it's being stripped. Okay? This is a translocation horizon. Organic acids are leached from above, and they can weather and strip this horizon. You can see this nice, very apparent E horizon right here. Above it is an A horizon with an H, which means humic material, basically accumulation of humic acids. Okay? Below it, it has H, that's organic stuff as well. Okay? This and this, these are really strong, pronounced E horizons. Okay? The color that you see is the result of the minerals that are left behind. Okay? When these soils were first seen, they were basically seen in forests. And people associated this, because of this white color, they associated this with forest fires, thinking that this was ash. Ash, A-S-H, ash. Okay? It was that white, and it is that sort of powdery in these scenarios. And that's why they thought it was forest fires. Turns out that's not the case. These soils, these are two spotted soils, this particular kind of soil we'll talk about later. But these are forested soils, and they're formed in sandier grain materials. Now, you guys have been to the beach. What's the color of sand? Sort of a whitish, clear, sort of manila color. That's where these colors are coming from. They're coming from the minerals, not from a forest fire. Okay? But we also have an E horizon right here. Now, this is not a forested soil, but you can see my A up here, horizon down below. This zone right in here has been stripped out. The coarser textures stay behind because the silts and the clays will be entrained with the water, and they'll move down. The organic matter will move down. Okay? What's left behind is this coarser stuff, and it looks lighter. Go. In this horizon, you can see an O horizon up, sort of up here. But in these, there's not much of an O horizon left. Remember me saying there's not O's in everything, and there's not A's in everything, or even E's. But go.
So the texture's different from each horizon. Does water move at different speeds in each horizon?
Yes.
Okay.
In fact, that textural change often predicts where these boundaries are going to be, where you can start seeing this stuff.
How do you tell the difference between the A and the O if they both have a lot of organic matter?
The O is all organic matter. The A is a mineral horizon with organic matter. It's the mineral horizon with the maximum amount of organic horizon, of organic material. If the organic matter accumulates enough, that A will turn into an O. Okay, B is a zone that's right below that E horizon, and it's a zone of illuviation. Basically, I, the way to remember this is in. This is a zone of accumulation. Okay, this is where all that alluvial stuff, eluvial stuff, basically comes down and is deposited. And that's sort of the definition of this horizon. It's a zone of accumulation. So alluvial clays that were entrained by the water, the dissolved irons and aluminums, the organic material, salts, silicas, all that stuff that was dissolved at the top is being moved down by the water. It's being deposited in this horizon. Okay? There are a number of different kinds of them, and you will learn them through the semester. But we're basically looking at, I can't quite see this one myself. We're basically looking at this zone of accumulation down here. Here's the specific kind of accumulation. This is that spotosol I showed you before, a very white horizon here. Organic acids, and what we call S stands for sesquioxides, which basically is iron and aluminum oxides that have been created from above, are moving down here and are being deposited here. Okay? Does that make sense? You will see these horizons. Okay? Here's a number of other special sort of horizon. This one, that's not a soil horizon. Okay, but it's okay. See these white spots in here? That's an accumulation of calcium carbonate. Okay, as you get farther and farther west, systems go drier and drier. Calcium carbonate starts accumulating. Okay, and they can accumulate into soil horizons. I don't know if I have another slide of this. I don't. Okay, I threw this one in here because this is basically the same process. Has anybody been to any of the caverns around here? And this is basically, so a couple of you guys have seen this kind of stuff, right? This is basically calcium carbonate. What's happening is there's a whole chemical reaction, but what's happening is the partial pressure of CO2 is shifting from the soil to the cave and from the surface. And what happens is the calcium carbonate basically solidifies. Okay? In this case, this is an extreme case where you're basically creating a stalactite and a stalagmite coming together and making a pillar. Okay? But this is basically the same process that you're seeing. Then these are small, tiny little aggregates that are in the soil. But this is a zone of accumulation. It's a diagnostic of a B horizon, accumulation of material. Okay? The next horizon down is the C horizon, which is partially broken down parent material. Okay? Technically, there's not supposed to be any kind of biological activity going on in here. So if you see roots or something like that, you're out of, it's not a C horizon, it's a B horizon or something else. Okay? But in reality, we do often see roots and things like that in here. But basically what we're looking at is parent material, undifferentiated material, stuff that has not been subjected to soil forming processes. Okay? Often you'll have a deposit. Now this is a deep lust deposit down here, so this is a material that's been deposited on something else, older. This sea horizon right here, this is the stuff that this is made of. It just hasn't been, the world has not acted upon it yet. It hasn't been subjected to change. Okay? Here's another example of different type of parent material. You're basically looking right in here, and this is basically a gravel bar. You see all the rounded rocks in here? Okay, this was probably a deposit from a river or something like that, and the soil is forming on top of that from stuff coming above and stuff being weathered away from below. Okay, this is the living soil in here. This is the sea material, so this is the whole soil profile, but this is the soil that's being formed. And this will ultimately move through this, unless something catastrophic happens. Okay, does that make sense with the sea horizon? There's another sort of exposure of a hole. You can actually see CA, you can see everything there. Okay, now I wanted to take a step back and sort of talk about some of the features that are in these soils. Okay, so here is the profile. This is a E, B, a couple of B's, a B, a BC, and we'll talk about what these combinations are later on. But what I wanted to show you is where the materials are within these soils. Certainly the first one, organic matter, makes sense. If I have a soil, where's most of the organic matter going to be? Up top, because that's where it's coming in and that's where the organisms are living, right? I mean, I got a plant growing, and around here every fall, I get a dramatic increase of organic matter on my soil, right? Leaves fall. Leaves hit the ground, okay? Organisms start taking that material and using it as food, and most of those organisms live up in the higher parts of the profile, and that's why the organic matter accumulates up there. Now, if I've got a lot of organic matter, that's when I'm going to get an O horizon. But in this scenario, we're looking at a mineral horizon that's enriched with that organic matter. Does that make sense? Okay. How about the clays? What's going on there? You can see that I have a huge bulge of clay farther down. I have a zone here where I'm lost. And then way down, there's not very much. And then I got a little bulge up at the top. What's going on? Any ideas?
Is the clay being washed out of the E horizon and collecting in the E horizon?
Yes, but a little bit more than that. It's not just being washed out, but it's also being washed out of this horizon as well. So it's getting washed out of here, it's getting stripped out of here, and it's getting deposited down here. Now the water is not moving far enough to deposit it all the way down here, and you start getting into, hopefully, the sea horizon. Remember, the definition of the sea is undifferentiated parent material. Stuff hasn't happened there yet. Once this clay starts accumulating down in the sea horizon, this sea horizon won't be a sea horizon. It will become a B horizon, because the B horizon is a horizon of accumulation. Does that make sense? Yeah? Okay. We can look at the same thing with iron. Iron is one of the major elements on the planet. Okay? The same thing is basically happening. This is a particle. This is being transported as a dissolved mineral. Okay? The same thing's happening. Okay, questions?
This has been a production of Cornell University. On the web at cornell.edu.